We're going to look at the rules of indices because it's one of the most popular topics that comes up on the GCSE examination paper. Out of the papers that you sit from the three papers, generally you will find a lot of index law questions come up on probably 2 out of the 3 papers, or you might be using it in some topics where it kind of sneaks in as well. Okay, so what we're going to do before we start, I'm going to ask you, while the rules of indices are displayed on here, is that you need to go and learn the following 2 things in particular. You need to know your square numbers. I would probably say for now, you need to know the first 15 square numbers off by heart in order for you to do these questions much quicker. And you need to know probably the first, I would say, 5 cube numbers. You can do 6 or 7, but the first 5 cube numbers are important. So the first set of square numbers that you need to know are as follows. 1 times 1, which is 1. 2 times 2, which is 4. 3 times 3, which is 9, and so on. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 15 square, which is 225. So you need to learn these first 15 numbers off by heart in order for you to understand in index law questions. So make a note of these, and when you get time, start to recall these numbers by writing them down on a blank piece of paper. Okay, you don't need to write the entire question out, like 3 times 3, 4 times 4, or 3 squared, 4 squared equals, and so on. You can just write down these answers. If you've got these answers off the top of your head, it turns out much quicker. So once you've got that, you need to know the first 5 cube numbers as well. So 1 times 1 times 1, which is 1. 2 times 2 times 2, be careful with this one. A lot of students write 6, it is 8. 3 times 3 times 3, which is 27. 4 times 4 times 4, which is 64. And 5 times 5 times 5, which is 125. Okay, so make sure you do the same with that. Learn these 5 as well. So let's look at the index laws. What we're going to do is, before we start, I want you to just learn 2 things because I might pop them up later in a second. We will come to the index laws using fractions, but please just know this for now. Anything to the power of a half, okay, because I'm going to see if you can remember this later. Anything to the power of a half is the square root of that. Anything to the power of a third is the cube root of it. Okay, so you need to learn these 2 things in particular, a half and a cube. So if I said to you, for example, what is 64 to the power of a half, you can replace the power of a half and replace it with the square root, and the square root of 64 is equal to 8. And if I said to you the same thing, what is 125 to the power of a third, it's got the 3 in there, so that tells you it's the cube root of 125. Therefore, the answer is 5. So those are the 2 I would like you to kind of learn, a third and to the power of a half, but we'll come to that in a second. All right, so once you've noted on these index laws, we'll keep referring back to them as well. The examples are also set here, so it shows you kind of how to do them as well. What we're going to do, we're going to first start off with the first law, which states that if you are multiplying, there we go, if you are multiplying and the 2 bases are the same, the 2 bases have to be the same. Therefore, circle the first power, circle the second power, connect them together and put a plus sign. Do not multiply them. Okay, that's a misconception. We add them together. So 3 plus 5 gives us 8. So the answer is x to the power of 8. Another one I'll just give you, x to the power of 7 times x to the power of minus 2 equals, again, the 2 bases here are x, so we keep the base the same as x. We've got 7, we've got a minus 2, we connect them, we add them together. The 2 powers, because one of them involves a negative, anytime any of the powers involve a negative, whether you're adding or taking away, always do it on the side. So you've got 7 plus minus 2. The plus and the minus, 2 different signs, means that you end up with a minus. So 7 take away 2 is equal to 5. So the answer is x to the power of 5. It is not x to the power of 9 because you see a 7 and a 2. Let's have a look at another one. Just change things around. 5 to the power of 4 times 5 to the power of 2. This time the two bases are a number over here, so 5 and 5. So we get 5 over here, we keep the base the same. And then we've got 4 plus 2, and it's equal to 6. So the answer is 5 to the power of 6. There was a GCSE examination question, be careful, which said 2 to the power of 3, for example, times, there we go, 2. And write your answer as a value. So what students did was, they saw the 3 there. They didn't see a power. Remember, you're supposed to have two circles, connect them together, and then add them. There wasn't a power. If there's not a power there, we put a 1 in there. So 3 plus 1 is equal to 4. So the answer, 2 to the power of 4. And if it was worth 1 mark in a GCSE examination question, you'd get 0. If it was worth 2 marks in a GCSE examination question, you'd get 1 mark for 2 to the power of 4. Reason is because the question says, what is the value? Which means we want an actual answer, not left in index format. So therefore, 2 to the power of 4 is the same as saying 2 times 2 times 2 times 2. So therefore, 2 times 2 is equal to 4, times another 2, which is 8, times another 2 is equal to 16. So if they ask for the value, you must give us the value. Do not leave it in index format. Just one more. Let's try this. 3 to the power of 2 times 2 to the power of 4 equals 3 to the power of what? So here we've got a 2, we've got a 4. Most students here are going to add them up because it's multiplication, but you can't do this question. The reason why you can't do this question here in this case is because the two bases are not the same. If the two bases are not the same, you can't do this question. It's the same as me saying x to the power of 4 times y to the power of 3. I've seen students write this in the exam, x, y, and then they take the two powers and they try and add them up. So 4 plus 3 is 7, and they put it all together. It doesn't work like that. If the two bases are not the same, you can't do this question. Okay? For the ones with a value though, if they do ask for a value for the top question, it means you've got to treat them separately, so you can't use the index laws here. So 3 squared gives me 9. 2 to the power of 4, we just did that, is 16, which then gives us 144. So you can do them separately, but you can't use the index laws here because the bases are not the same. The next question I would like to do with you is this one. So if I said to you, t to the power of 5 divided by t to the power of 2. This time we've got divide. So again, we circle the two powers, we connect them together, and we put a takeaway sign. Because we're dividing, okay, we subtract the two powers. So therefore, the bases stay the same. So we keep it as t. 5 take away 2 is 3. So the answer is t to the power of 3, or t cubed. We can then do it again with numbers. They love using 7s. I've seen in exams a lot. 7s and 5s come up quite often. 7 to the power of, say, 8. Divided by 7 to the power of, let's say, 2. Again, don't rush into the question. Circle the two powers, connect them, and put a subtraction sign. 8 take away 2 is then 7 to the power of 6. And if they ask you for the value, then you can do 7 to the power of 6. But for now, we just keep it in terms of index format. Another one that I'm going to give you, let's have a look, see what you work out this one. What did you get for this one? X to the power of 6 divided by x to the power of minus 3. I'll let you pause it and just have a go at this one. Tell me what you get. Okay, so again, we circle, connect, and put a minus. Now, because there is a negative involved, we do the working out on the side of the exam paper. So then we have 6 minus 3, because we have a minus here and a minus inside this circle. So 2 minuses give us a positive. So 6 plus 3 is equal to positive 9. So it's x to the power of 9. Let's try another one, please. Let's try 5 minus 4 divided by 5 minus 3. So again, minus 4, minus 3, connect, take away, write the numbers out. So minus 4 minus minus 3. Two negatives make a positive. So minus 4 plus 3 is minus 1. So therefore, it's equal to 5 to the power of minus 1. You might see in the GCSE exam question where they sometimes write it like this. So we've got the fraction over here, so it looks like a fraction now, which is the division sign. Again, have a look at the bases. Are the bases the same first? Yes, they are, so we keep the bases the same. And then we've got 7, and we've got a 5. This time you can connect it going down. There's the takeaway. So 7 take away 5. Some students like to write it like this as well on the side. 7 take away 5, which is quite nice. And therefore 8 to the power of 2. And if they ask you again for the value, 8 squared therefore is 64. So why do we also use this? Because questions though can turn out to be like this. So I can do 3p 4q2 times 6p2q5. So because it's multiplication, we go back to the first law that we've used. And this time, just be a bit careful with this, okay? The laws apply, remember, to powers only. So here we have got, I'll underline, we've got a 3 and we've got a 6, and we're multiplying. So those aren't powers. So they are just our integers that we're using, okay, that are in front, our whole numbers. So 3 times 6 gives us 18. So that's done. Then you've got P4 and P2. So what I can do is, we've got powers involved, so connect them and put the plus sign. Why the plus sign? Because we're multiplying. So 4 plus 2 gives me P6. And then you've got, use another color, Q2 and Q5, connect those together, add them together. So therefore, we get a Q, and 2 plus 5 gives me 7. We put the answer together, our number, our P, and our Q, and we get 18, P to the power of 6, Q to the power of 7, all as one. Try this one, please, on your own. I'll pause the video, have a go, and see what you get. So we've got 7 times 6, which is 42. We've got t to the power of 4 times t. Remember, there's no power on the t, so we put our 1 there because there is a 1 there. So we've got 4 plus 1. We add it together, so that gives us t5. And then you've got 7 and minus 2. We've got a negative involved, so let's do it on the side. So 7 plus minus 2. Plus and a minus gives me a minus, so 7 take away 2 is 5. Therefore, we end up with r to the power of 5. Our next index law states that if you've got a power in a bracket with a power on the outside, okay, so a power outside of a power, we circle, connect them, and we multiply them. Because it's the same as me saying, I'll show it to you at the bottom, x3 times x3 times x3 times x to the power of 3. We've got 1, 2, 3, 4 of them because it's to the power of 4. And what do we do when it's multiplication? We add up the powers. So if we add them up, we get 3 plus 3, which is 6, plus another 3, which is 9, plus another 3, which is x to the power of 12. But what we can do is, if we have a power outside of a power, we multiply it together, so we get x to the power of 12. Let's try another one. Let's try y5 minus 2. Again, circle the two powers. Have you noticed on each of the laws, I'm just circling the powers all the time and connecting them. And then this one's a multiplication. Base stays the same, so it's y. And 5 times negative 2, 5 times negative 2, positive times a negative gives me a negative 10. Let's try one with the number 2 to the power of 3. Let's put a minus 3 and put a minus 8. Here we go. So keep the base the same, the 2. Negative 3 times a negative 8. Please do it on the side. 2 negatives multiplied together makes a positive. So 3 times 8 gives me 24. So sometimes students ask when this comes up in an exam paper, okay, because they get this bit wrong. So let's have a look at it together. So they get something like this, where we've got a number with a letter and a power and another one. And then what we've got on the outside, we've got a power. So here, the law does apply again. Power with power, we multiply. But before we do that, because this is worth around 2 marks, and if you notice, you've got a 2 here, x to the power of 3, and y to the minus 4. You've got 3 items over here, okay? And they're worth around 2 marks. And generally, a lot of students do score 1 out of 2 because they don't focus on the 2 in the front, okay, or the number in the front. So let's do this. Just watch how I do this really carefully. What if the x3 and the y to the minus 4 did not exist? What are we therefore left with? We're left with 2 cubed. So we've got the 2 here and we've got the cubed here. So 2 cubed is equal to 8. Okay, this is the one students forget. I'm just going to undo this for a second. There we go. So that's the one students forget. So we've got 2 and a cube, and it's equal to 8. Then let's do our power and our power. We've got a 3 and a 3. We multiply, we don't add. So therefore, x3 with another 3. Remember, power outside of a power gives me x9. The last one that we've got minus 4 and a 3. Let's connect them and multiply them. So we've got y minus 4 with a 3. And if we multiply it, we get y minus 12. So we've got 3 things here. We've got an 8, x to the 9, and y to the minus 12. If we put them together, we get 8, x to the power of 9, y to the power of minus 12. We can put them all together, and we get an answer. So that's why the bracket is so important to understand what you're going to do next. Let's try this one, though, and I'll let you have a go at this. So 3x, let's try 4, y, and t to the power of 2, and let's put a 3 out here. So pause the video, have a go, and see if your answer matches mine. So 3 cubed, look how I'm doing a lot of underlining. 3 cubed gives me 27. That's the one students forget. 4 times 3 gives me x to the power of 12. There's a y here, but there's no power, so we put a 1 there. So therefore, 1 times 3 gives me y3. And then you've got a 2 times the 3. Everything we're multiplying with a power gives me t to the power of 6. Okay, the next law that you need to understand is anything to the power of 0 is equal to 1. So for example, a to the power of 0 is 1. X to the power of 0 is 1. Y to the power of 0 is 1. They can put it with a number. So they've put sometimes before 154 to the power of 0. Most common answers that students write, for example, are 154. They keep it the same. That's wrong. They write the answer is 0 because if they see anything, they think it's multiplied with 0. Anything that's multiplied with 0, they think it's 0. That's completely wrong. I had one student when they saw 154 with a 0 on the top, they wrote the answer was too hot. So they thought it was the temperature. That's wrong. So again, even if the base is 154, anything to the power of 0 is equal to 1 as stated. The next one that we're going to look at is this. If I said to you, what is 3 squared? I expect you to give me the answer as 9. If I said to you, what's 5 squared? I expect you to give me the answer as 25. But let's change the question slightly. Let's now put a negative in front of the power. So by putting a negative in front of the power, we still apply the same rule. We do 3 squared, which is equal to 9. The only difference is a negative in a power does not mean minus 9. It's the most common misconception answer that students write. It is not negative 9. So let's get that out of the way. A negative simply means the reciprocal. Okay, or some people call it, you flip it. So it becomes 1 over 9, and that is the answer. That's it. If you've got 5 squared, which is 25, but there's a negative in the front, it becomes 1 over 25. So you find the reciprocal of it. So if I said to you, what is, let's make it interesting, x minus 3, there we go. Just ignore the negative just for a second, and then therefore you're just left with x cubed. By having the negative in there, so I'll just bring that back, it means you find the reciprocal of x cubed, so it's 1 over x cubed. The next one, this is the one that's slightly the higher level. Now it's the ones with the fractions on the top. Okay, so if I said to you, let's pick a number, let's do 25 to the power of a half, and I asked you to remember this at the start of this video. So anything to the power of a half is a square root, so it becomes square root of 25, so the answer is 5. But what I want you to do is, I want you to kind of have a look at this here, how they've done it here. I'm going to show you a way which is quite nice. I want to rewrite the question out again, but we can do this with any fraction. And what you do is, you take the bottom denominator and you bring it to the outside of the 25. So therefore, I'll bring the 2 on the outside, put a root in there, put the 25, and see that 1? That stays here on the top, and I'll put the 1 there. Now this here does not mean, it's not primary school division, this is a root. This 2 in the front means what two numbers, same two numbers, multiplied together to make 25. Remember those square numbers you had to learn at the beginning of the video, verse 15. So what square numbers, okay, what two numbers multiplied together to give you 25. So it's 5 times 5, which gives 25. They have to be the same number, by the way. Can't be two different numbers, the same number. That's why they're square numbers. 5. So this entire bracket is equal to 5. And then you've got a 1 on the top as a power. So 5 to the power of 1 is equal to 5. And that was the answer that we've got here. Let's try another one. Let's try, I'll give you a nice one to actually do. Let's do 27 to the power of 2/3. Watch what happens here. We're going to take the denominator and we're going to bring it to the outside. It's okay in the exam if you draw these arrows as well. It helps us. So the 3 goes on the outside. The 27 goes inside the bracket, or inside the root as well. And then the 2 stays on the top. Okay, stays flying on the top. The more you practice this, the better. So what does this mean? It means what is the cube root of 27? Or what 3 numbers, same 3 numbers, multiply together to give me 27? So this time you need to look at your cubed list. So if you look at your cube list and you find 27 on there, what 3 numbers, same 3 numbers multiply to give you 27? The answer is 3. Because you've got a 2 on the top, the square on the top, please don't forget it. You just drop it back here again, and 3 squared then gives us 9. So the answer is 9. Let's try another one. Let's try 16 to the power of 3/4. Okay, so before we start, don't try and answer the question. I'm not asking you to work out what is 3/4 of 16. Remember that. We take the 4 and we bring it to the outside. Follow the pattern. There's the 4. 16 goes inside the root. So we're finding the 4th root of 16. And then what do we do with the 3 at the top here? We keep it on the outside. So we're going to use that later. So this means, a bit different here. It's got a 4 on the outside. So it means what 4 numbers, same 4 numbers multiplied together, that gives me the 16. It is not how many 4s go into 16, which is 4. It is not primary school division that you did back in the old days, where you had the old division sign like that. Okay, it's a root. So therefore, if you're not sure about this, start with 1 in your head. You should be knowing this, but start with 1 in your head. Okay, and then work your way with 2, then 3, then 4, and so on. Honestly, they will not ask you really complicated numbers at the moment. The aim is that if you can try and use basic square cube numbers or numbers that are to a simple root, and in order to put this in, just the strategy on how to actually calculate the laws of indices. So if I used 1, for example, 1 times 1 times 1 times 1, I get 1. I don't get 16. So you try the next number, 2 times 2 times 2 times 2. Let's try this, please. So 2 times 2 is equal to 4. 4 times 2 is equal to 8. 8 times another 2 is 16. So this entire bracket here is 2, because that's what makes the 16. So there's the 2. Don't forget the cube down here. So 2 cubed is equal to, it's not 6. 2 cubed is equal to 2 times 2 times 2, which is equal to 8. I'm now going to change the question around. So let's do 125 to the power of minus 2/3. Okay, so this one also involves the law that we did previously with the negative. So we need to flip the answer, but we flip it at the end. But what we're going to do first, we're going to follow the rules. Let's ignore the negative for now. What I'll do though, I'm going to write here, flip. So I'm going to remind myself in the examination paper, I need to flip it or find the reciprocal. But let's follow the rule first. So there's 3, the cube root, got the 125, okay, and then it's in the bracket, and then the 2 is on the top. So the numerator stays on the top. So this tells me what is the cube root of 125, or what same three numbers multiplied together to give me 125. So the answer is 5. We keep the square on the top here. So 5 squared is equal to 25. Oh, but what does it remind us at the end? What was the purpose of the negative? Okay, the negative meant if a power has a negative, you need to find the reciprocal of 25. So the answer is 1 over 25. There was one question in the GCSE exam that I saw. It's quite a good question, and it was like something like this. It said 8 over 27. Okay, and it had, again, say let's put minus 2/3 here. So students ask, but which one does it apply to, the top one or the bottom one? We're not sure. So the rule was that you had to apply this 2/3, power of 2/3, to both of them. So it looked like this. I'll do the one with the 8 first. So the 3 goes on the outside, the 8 goes inside the root, 2 goes on the top. Divide by, there's the divide line. Again, you do the same. So there's the 3, there's the 27 inside, and then there is the square on the top. So this time it's, what is the cube root of 8? So what three numbers multiply together, same three numbers multiply together to give you 8, and the answer is 2. And don't forget to, so I put 2 here and then square. So the answer becomes 4 on the top, over, what's the cube root of 27? So that was 3. 3 square, and therefore becomes 9. So it's 4 over 9. But don't forget, there's a negative here. So what do we do when there's a negative here? This time, we flip it. So how do you flip a 4 over 9? Because it's already already in a fraction, it becomes 9 over 4. So you just swap the 2 around, and that's how you find the reciprocal. I'll give you one to try for yourself. Pause the video, have a go at this, and see what you get. So it should have looked something like this. This is how you should have done the layout of the first one. Second bottom denominator should have looked like this. In the bracket should have been 5, so 5 squared gives me 25, and 4 squared gives me 16, so the answer is 25 over 16. Please don't forget, look for the negative. The power is a negative. If that's the case, what happens to the 25 over 16? Okay, we find the reciprocal, therefore it's 16 over 25. There are some high-level GCSE questions that come up on indices. I've only gone through basic rules, but I'll just go through kind of one with you, a really popular one. I'll show you maybe another one in a sec. And it was like this. It was 2 to the power of 5 times 8 equals 2 to the power of n. What is the value of n? So in this case, you can't do this question because the rule was, if you remember, all the bases have to be the same. So you look for the lowest base. So you've got 2 here, you've got 2 here, but you've got an 8 here. So this 8 we have to change. It has to have the lowest base 2, so everything is in order. So the 2 to the power of 5 stays the same, and the 2 to the power of n stays the same, and we need to change 8 with a base of 2. So we're going to put a 2 here, and you need to tell me 2 to the power of what is equal to 8. So I need to replace that 8 with a base of 2. So 2 to the power of 3 gives me 8. So you can replace 8, okay, with 2 to the power of 3. What do we do now when it's multiplication? Now that all the bases are the same, we can now add them. So therefore, 5 plus 3 is equal to 8. Therefore, 2 to the power of 8. Therefore, n is equal to 8. Let's try another one. So if you look over here, we've got a base of 3, a base of 3, but this is not a base of 3, so I need to change that so it's got a 3 in there somehow. So in order for me to get that 27 with a base of 3, I'll just do it on the side. Okay, I know that to get 27, if I do 3 cubed, I can equal that to 27. So I know that this definitely must be 3 cubed. I also know that because it's got a square root on there, square root is anything to the power of a half. I also know that if I multiply the 3 with the half, because it's a power outside of a power, and I times it, I get 3 to the power of 1.5. So what do you think the answer is of n? Pause the video and have a go. So if we multiply, we add the powers up, so 2 plus 1.5 is 3.5.